first, for those who might not be familiar, can you give us a quick description of what easy or exclusion zone water is?
Uh, well, quick description. Let me
I know that's hard.
how to make it a quick description. It's a kind of water that's unlike liquid water. In liquid water, the water molecules are randomly oriented and they're bouncing around a fierce number of times per second or per femtosecond. Easy water is a kind of, you might say, structured water. That term was originated by, I think, by Gilbert Ling and others, who was a pioneer in the field, and it's actually a water that is liquid crystalline. In other words, the molecules are organized in some way, like soldiers at attention.
Yeah.
So that's what just in general that's what we're talking about when we're talking about easy water or fourth phase water. The two are the same.
Right. Okay. And so why is there a charge separation? I know you talk a lot about that, the idea that the protons and the actual EZ is negatively charged and then the rest is not. Can you explain that a little bit?
Yeah, yeah, it happens. It's perhaps the most important feature, because if you have charges that are separated like that, you have a battery, and that battery is capable of delivering energy, and we've demonstrated it. We have proof of principle that it actually can do that. Um, so the way it forms is, um, in general, there's several ways it forms, but one of the principal ways, the way we saw it first, is that we take a gel, um, and we immerse it into a bath of water, and in the water we have little particles, and the idea that we started with was that if there's a region of water that is like a liquid crystal is a bit like ice, except that ice is hard and it occurs at a low temperature, but everything is organized. And if it's organized like a crystal, crystals tend to exclude pretty much everything. Otherwise, they would be pure crystals, if they had impurities in it. So
Yeah.
as the crystals are forming, they get rid of, I'm sorry, you have a question?
No, keep going.
Oh, okay.
Yeah.
Yeah, they get rid of the impurities. So we were looking in the microscope to try to find a region uh, where the particles, or we use little spheres, microspheres, where they were excluded, and we found it right away.